Okay, shall I start now? So this one will be the last topic of this chapter, and that is what? AT graph. Acceleration time graph. Okay, before starting this graph, generally we learned two types of graphs earlier. One is XT graph and one is VT graph. XT graph will provide you velocity, that is instantaneous velocity. Yes or no? That means the slope of XT graph will provide you what? Instantaneous velocity, and the slope of VT graph will provide you instantaneous acceleration. Yes or no? If I want to calculate the slope of AT graph, then if m is nothing but dy upon dx, maybe general equation of slope, and then can I write d of a upon dt. So dA upon dt does not provide you any kind of physical quantity. Okay, then what does it provides you? Now it only comments on acceleration. dA upon dt, nothing but rate of change of acceleration with respect to time. Meaning, consider a body is moving in this direction and initial position is A and the final position is B. In this journey, if acceleration at any point is 2 meter per square second, then can I say acceleration is constant and acceleration is positive? Similarly, can I also say that acceleration can be having 2 meter per square second with a negative value? Then we call this as what? Retardation. Yes or no? And can I also say that acceleration at t is equals to 0 may be having value 2, and t is equals to 1, it will be having 4, at t is equals to 2, 6, 8, so on. If the acceleration is increasing in this rate, okay, or from here it is decreasing with the same rate, then we will be calling that acceleration increasing or decreasing. Okay, either the acceleration is increasing or decreasing, but what? With constant rate. But with what? Constant rate. If the acceleration is changing like 2, then 10, then 15, then 25, then 50, so on. Either in this direction increasing or in this direction, in the reverse direction decreasing, whatever the scenario is, if such thing is happening, then acceleration is increasing or decreasing with what? Variable rate. Okay, so what we need to understand, or what dA upon dt will provide you? These things. Okay, so dA upon dt, that means AT graph will provide you the data, what is the behavior of acceleration. I got my point? It will provide you what? The behavior of acceleration. Shall I? Okay, now listen to me. Let us move to the first graph. Consider here is A, here is T. If I represent with a straight line parallel to the x-axis, then can I say acceleration is constant? Second thing, can I also say that acceleration is positive? So in the first graph, can I say that acceleration is constant and acceleration is what? Having a positive value. Similarly, if I want to represent in the second way, don't write anyone. If I represent a graph like this, so this is your acceleration, positive acceleration, this is your negative acceleration, this is your time. Then can I say that if this is your A naught? Can you comment on this? Yes, acceleration is constant and negative. So in this example, can I say that acceleration is constant, but acceleration here is what? Negative. The third thing, if I represent like this, here is your acceleration, here is your time. Okay, then this type of graphical representation will provide you the data of acceleration is increasing. First thing, what? Acceleration is what? Increasing. Second thing, acceleration is positive. But what is the rate of change in acceleration? Can I say constant? So acceleration is increasing, but its rate is, acceleration is increasing with, can I say constant rate? Constant rate in this one. Or can I also represent like this? So here is your acceleration, here is your time, origin. In this one, this graphical representation, this graph is telling you that acceleration is increasing, but with variable rate change. I got my point. So here acceleration, first thing is positive, acceleration is increasing. Acceleration is increasing with what? With variable rate. I got my point. So in this one, in AT graph, generally we will only comment on what? Acceleration. It will provide you the data about velocity, about displacement also. But generally we will only comment on what? Acceleration. Okay. Right on. Okay. Shall I? That is what? How many completed? 4, na? 5. Okay. Now. Yes, tell me. So that can be happening now. Then if you want to draw like this, here is your positive acceleration, here is your negative acceleration, here is your time. The question is, can acceleration be negative and increasing with variable velocity? Yes, it can be. Then the representation will be like this. It is increasing. Yes, it is increasing. With variable velocity? Yes, with, variable acceleration. So can I say that acceleration is increasing with what? Variable rate. Variable rate. And over here, and it is what? Negative. Okay, we can write like this also. Okay, now the fifth one is origin, this is your acceleration, this is your time. Okay, now tell me. Already we have seen this diagram previously twice, na? Yes or no? Okay. Okay. Now, what about acceleration? Let's say this as point A, again this has your point B, and this has your point C. Let's say A to B. A to B, acceleration is increasing or decreasing? Yes. Increasing. So A to B acceleration is what? Increasing. Is it positive, negative? Yes, it is positive. Okay. Can I say that at B it becomes maximum? Very good. So at B acceleration is having a maximum value. Or can I also say that from B to C acceleration is decreasing? Yes. Okay. Constant or variable rate? Variable, yes. So acceleration is increasing here with what? Variable rate. Here also it is decreasing with what? Variable rate. Okay, shall I now write the next heading, that is what? Graph comparison. Okay. Now you will be telling the answers. First, I will ask the question, you tell the answers. Okay, everyone, got my point? Now, over here, this is xt, and over here, I will be saying vt, and over here is what? at. Okay, now, your first question is, this is your x0, this is your x, this is your time, this will be 0. Okay, now one more thing, no one will be telling unless I keep quiet. Okay, shall I know? Now tell me the vt for this. 0? Yes, very good. So if a body is at rest, vt is also 0. Okay, 0, very good. So acceleration is also 0. Okay. Now the second is This is your time, this is your displacement, 0. If I draw like this, VT, straight line, yes. This is your V, this is your T, this is your 0. Can I say that acceleration is, velocity is constant here? Velocity is constant? Yes. Can I say acceleration is 0? 0 or constant? 0. Then can I represent over here with what? Again 0. Are yes or no? Yes? Okay, right on. Third case. And like this. Tell me VT. Straight line from origin or from anything? Parallel to x-axis? No, na? Okay. So can I draw like this? This is your velocity. This is your what? Time. This is 0. Can I write like this? Acha. Here, what is happening? Velocity is increasing or decreasing? Yes, velocity is increasing. Positive, negative? Positive. Very good. What about here? Acceleration? Constant. So here acceleration is what? Constant. Positive, negative? Positive. Okay, similarly, tell me AT. No one will be telling unless I complete the diagram. This is your A, this is your T, this is your 0. That is origin. Huh? Yes, very good. Parallel to the x-axis. Why? Because A is what? Constant here. Are yes or no? Okay. Okay, shall I? Example number 4. Or graph number 4, whatever it may be. This is your time. This is your displacement, origin. Now, what is the velocity at this point? 0. Yes, very good. Velocity is what? 0. Let it may be A, this is B, and this is C. A to B velocity is increasing, decreasing? Decreasing. So, A to B, what? Velocity is what? Decreasing. And B to C, velocity is increasing. This one, velocity is positive, negative? Positive. And this one, negative. Okay. Now, drawing the VT graph for this one. This is 0, this is your V, and this is your T. Now tell me, do it has initial velocity? Yes. If it is having some initial velocity and finally from A to B in the positive direction, what is the velocity at point B? 0, na? So can I say like this? So this is your A and this is your B. After B, where the body is going in the negative direction? Yes or no? Okay. So then can I continue this like this? Are yes or no? Okay. This positive velocity is getting decreased. If positive velocity is getting decreased, then who will decrease that? Can I say negative acceleration? So from here to here, acceleration is what? Negative. And from B to, let's say this point is C, who will increase the negative velocity? Again, negative acceleration. Yes or no? Then can I say that AT graph will be looking like this? This is your A, this is your T. Then A to B, again negative. Yes or no? And B to C is also negative. I got my point? Yes? Not down. Okay, example number 5. Now the graph is like this. So this is your X, this is your T. Shall I? Okay, what is the velocity again here? 0. So velocity at this point is 0. It will be having velocity at A. At B, velocity is 0. At C, velocity will be having some value. So from A to B, increasing, decreasing. Can I say A to B negative velocity already? Negative velocity is decreasing. Yes or no? So negative velocity is decreasing means, can I say there will be a positive acceleration. Yes or no? So negative velocity, first thing negative velocity, and it is decreasing. And from B to C, again negative velocity, and this negative velocity is increasing. Or B to C velocity is what? Positive. Yes, very good. So B to C velocity is what? Increasing. So positive velocity is increased by whom? Positive acceleration. Then how to draw this Vt? This is V and this is your T. Okay, now how to draw this? Initially it is having negative velocity. So negative velocity means I have to start from here. Like this. So can I say this is your A, this is your B, and somewhere over here is C? Similarly, can I also draw AT graph like this? This is your A, this is your T. Now the acceleration is what? Positive. In both the cases, acceleration is what? Positive. Then can I say that this A naught is constant? Are yes or no? If you want to mark point A to B here, B to C. Are you got my point? Are yes or no? Right now. Okay. Let me understand by this also. This is your X, T, initial velocity. Just don't tell me anything. Just tell me initial velocity. 0 now. Why? Because what will be the velocity here? 0. So initial velocity is 0. Moving towards negative side. Velocity increasing, decreasing, increasing. Then how to write this one? So can I write this one? It will be Vt, AT. Again, the same thing. Same thing can be represented in a different form. Are yes or no? Ardhamainda everyone? Example number 1. Vt graph is given. Okay. Vt graph is given and the Vt graph is like this. At t is equals to 0. This is V and this is your t. And it reached to this point. Let's say t1. Then it reached to this point t2. Then later it moved in this direction and reached here at time t3. Question is draw xt and at graph. Try this. Let me draw the xt. So this is your x, this is your t0. Okay. Then how to draw that? Whenever you will be finding velocity like a straight line, then I am having a graph of xt like this. Yes or no? Okay. Then can I draw like this? Yes or no? So velocity is increasing or decreasing with respect to time? Yes. Okay. Then next, consider so t1 and I reached here t1. Then from t1 to t2, what is happening? Velocity is increasing or decreasing? Decreasing. At t2, what is the velocity? Can I say at t2 velocity is 0? At t2 velocity is what? 0. Now how to draw that? If velocity is decreasing, then can I say that this can be drawn like this? At this point velocity becomes what? 0. Slope 0 hota hai na idhar? Are yes or no? So object reached here at t is equals to 2 seconds or t2, whatever it may be. From t2 to t3, from t2 to t3, what is happening? Velocity is increasing or decreasing? Increasing. If velocity is increasing, then I am having a xt graph like this. Are yes or no? Then can I represent this like this? So this is your time t3. This is your time t2. Aya? Okay, thank you very much. Similarly, if I want to draw xt, so sorry, xt is over na, at. Consider this is your at. Acceleration, this is your negative acceleration, 0, and this is your time t. Okay, 0 to t1, what is happening? 0 to t1, what is happening? Velocity is positive? Yes, velocity is positive. Acceleration is constant? Yes, acceleration is constant. If velocity is increasing, if velocity is going in a positive direction and acceleration is constant, then can I represent like this? So till t1. So 0 to t1, this is happening. Okay. Then next, from t1 to t2, what is happening? Velocity is decreasing. Yes, if velocity is decreasing, still velocity is positive, negative. From here to here, velocity is still positive, but it is decreasing. So positive velocity is decreased by, can I say, negative acceleration? Yes, very good. So from here, let's say t2. So this is your t1 and this is your t2. At t2, velocity becomes 0. At t2, velocity becomes 0. From here to here, velocity is increasing. If velocity is increasing and it is increasing in negative direction, who will increase that velocity? Negative acceleration. That means, so I can continue this line till t3. This is your t3. I got my point. So one more time. Initial velocity 0 at this point. No, at this point, yes. So initial velocity is 0 and this final velocity is 0. That means from 0 to t2. I got my point. And it is having a maximum value, then maximum value to decreasing. So everything is represented like this. Are yes or no? Okay, right on. Okay, example number 2. Again, Vt is given. You need to draw xt and Vt. Sorry, xt and At. So this is your V, this is your T, 0. This is happening at T1, this is happening at T2, this is happening at T3. Draw xt and At. Let me do the xt. Check your answers, please. Time, and this is your x origin. Let's say A, this has B, this has your C, this has your D. A to B. Constant velocity. Constant velocity, then displacement can be written as like this. Yes or no? So this is your A, this is your B done, and it reached at time T1. Yes or no? Okay, very good. Then from B to C, what is the velocity at this point? At C, velocity is getting 0. At C, velocity is getting 0. At B, it is having some velocity. Then to draw that, I can draw this as like this. So at this point, can I say slope becomes 0? So velocity becomes 0. And this point we named as C. This is at time T2. Similarly, then C to D, velocity is increasing. But increasing in which direction? Negative direction. So can I continue this like this? Are yes or no? Yes. So this is happening at T3. This is point D. How many of you got this answer? Yes, excellent, very good. Let's see AT. A, this is your T0. A to B, what is the acceleration? 0. Yes. So 0 acceleration from here to here. So this is your A, this is your B. No need to represent, but even though for explanation I am representing. So 0 acceleration. Then B to C, what is happening? Velocity is decreasing. Positive velocity can also be decreased by negative acceleration. Yes or no? Then can I say that from here B to C. So this is your again B and this is point your C. Then next C to D, velocity is here negative. Negative velocity and it is increasing also. So negative velocity is increased by, can I say, negative acceleration? Then can I again continue this from C to D? Are yes or no? Now represent the time. Here is T1, at this point T2, at this point T3. Can I? Okay, note down. 3. Example number 3. Again VT is given. It is started here, then moved here, okay, then moved here, then let's say again here, then here. Banao beta. So this is your V, this is your time t, 0, t1, t2, t3, t4, t5, t6, here t7. Draw xt and vt again. Same question. Okay, shall I? So let me draw here. First is xt. Now, listen carefully. A to B, naming ceremony. So this is your A, B, C, D, E, F, G, H. Lay. Now tell me, A to B, what is happening? Velocity is increasing. If velocity is increasing, the curve should be like this or like this. Kaisa hona chahiye curve? Tell me, A to B, what should be the curve over there? Can I? Okay, thank you. Thank you, thank you very much, thank you. Now, so from here to here, A to B. So this is your point A, this is your B. This is happened at between 0 and T1. Then next, B to C, constant velocity. Constant velocity means straight line. Yes or no? So here, B to C, again, constant velocity. So this is happening at T2 na? Here let T2. Okay, then T2 to T3, here velocity becomes 0. Yes or no? That means can I draw the curve like this? Why? Because at this point velocity becomes 0 in xt. Yes or no? Okay. So here velocity becomes 0. So what is that point? D. Point number D, and it is at time T3. Then now T3 to T4, velocity is increasing, velocity is negative, definitely acceleration is also negative. So what is happening? Velocity is increasing from 0 to maximum na. Then can I draw like this? Continuing this like over here. So this is your point at T4 and point number point E. Okay, then next, from here velocity is decreasing, negative velocity is decreasing, positive velocity, negative velocity is decreasing. Definitely acceleration over there will be positive. I got my point. Okay, then how to draw this? No, like this. Yes, very good. Then can I continue this over here, negative direction, and at this point again velocity becomes 0. So what is this point? T5 na? So this is your T5. Then from T5 to T6 velocity is increasing, and it is increasing in positive direction. Definitely acceleration will be also positive. Okay, now then can I continue from here to the value over here? Are yes or no? Then next, this is your T6. T6. Then T6 to T7, uniform velocity. Then can I continue this like this? Are yes or no? So this is your T7. I got my point. So this is your xt. Similarly, let us try and understand to draw AT. Let me draw AT. So this is your A, this is your T. Okay, A to B, velocity is increasing. Positive direction, negative direction. Positive, yes. Then can I say from here to here, positive acceleration. So this is your A to B. Then B to C, constant velocity acceleration 0. So here is the 0 acceleration. Then next C2, sorry, B to C is over, na? B to C is over. C to D, velocity is increasing, decreasing, decreasing. Positive velocity is decreased by negative acceleration. That means, can I say that from here C to D is like this. So this is your C and this is your D. Then next C to D. Yes or no? Okay. Then next thing. C to D is over, na? Where is D? Here. Then D to E. Negative velocity. Negative velocity increasing or decreasing? Increasing. So negative velocity is increased by whom? Negative acceleration, positive? Negative acceleration. Okay. So can I continue this till here? Let's say this point name is what? E. E. Till here completed. Then negative velocity is decreasing. Negative velocity is what? Decreasing. Negative velocity is decreased by, can I say, positive acceleration? Yes. Then from here, let's say it reached here, increase. That means D, this is your E and this is F. So E to F acceleration is what? Positive. Then again from here to here velocity is increasing. Why? Because here velocity is 0 and 0 to maximum velocity is increasing. It is in positive direction. So positive velocity is increased by whom? Positive acceleration. Then can I say like this? Then this is your point number G. Point is what? G. Then points G to H. Constant velocity acceleration 0. Okay. Are I got my point, everyone? Note down.